Hey everybody, ABC 10 meteorologist Brendan Minchef. We're going to talk about the water year that was, because I'm recording this on October 1st, and that is the first day of the 2025 to 2026 water year. We're also going to look ahead at the expected La Niña winter. More or less, we'll go into more detail about that, but we'll also take a look at the seasonal forecast model and what we might be looking ahead towards by the time we get into the winter months. But first, we're going to look back at the water year that just wrapped up. Again, that starts on October 1st and it ends at the end of September. This is what we had. This is more or less a calendar starting in October. Didn't really have much, if anything, in October. Similar in November. Once we got closer to Thanksgiving and the end of the month, then we had a longer duration atmospheric river event for Northern California. But again, that was at the end of November. That's when we started to really add into our water year bucket, if you will. December saw some weak atmospheric rivers that kind of wrapped up right around the end of the calendar year. January was pretty dry, and you can see that's when we had those Los Angeles wildfires, the big ones, the Palisades and the Eaton fires, because it was just historically dry down there, and there was the extreme Santa Ana wind events. Even here in Northern California, it was very dry. Hardly a drop of water fell across Northern California in January. Thankfully, we made up for it in February and March with multiple weak atmospheric rivers. By the time we got to April, we hit our peak snowpack. Technically, that usually happens on April 1st, but we had one kind of late season push of rain, and so our peak snowpack was a little bit later than April 1st, but it was 97% of average. That obviously is good news. That got us about where we'd expect to be, where we'd want to be, so we're okay with that in terms of what we saw this year. Once we get into May, we start talking about snow melt, and then our water levels start to rise as all that water melts out of the Sierra and starts to work its way down. We had some minor showers over the summer, but honestly, that type of thing does not really impact our water year. Whether or not we have a few stray showers or a thunderstorm in the summertime, it really does not make a difference for us. Because when we're talking about rain, our rainiest months are not during the summer like in other parts of the country. As we know, that happens in the winter. But again, this water year just wrapped up. For Sacramento, well, here's what the numbers looked like. So for September, it was pretty dry. We didn't really see much. Normally, we don't see much in September, but it is kind of the turning point where we have that potential to see a few showers, whereas we don't really see anything at all in July and August. We average almost zero in the bucket. Literally, our average is zero for the month of July in terms of rain in Sacramento. But for the season as a whole, the water year as a whole, right? Last season, October 1st, 2024 to September 30th, 2025, we saw 13.81 inches of rain. It's a little bit below our normal. Our average that we would typically see through that period is about 18 inches. So we were close to 4¼ inches below normal for the water year. That's okay. It's not great. Obviously, we would love to see those 4 inches, but we've certainly had far worse rainy seasons and water years for California and for Sacramento. It was very dry, though, across other parts of the Southwest. So this is a map of the U.S. Southwest: Colorado, New Mexico, Arizona, Utah, Nevada, and of course, California. And we can see parts of far West Texas down here out towards El Paso. What this is showing us, it's divided up into climate districts. And what it's showing us is areas of the Southwest that saw a wet water year and areas of the Southwest that saw a dry water year. The darker the brown, the drier it was, the greener the green, the wetter it was. Well, across Arizona, it was very, very dry, historically dry. These numbers go all the way back into the 1890s. We are talking about top 5 driest water years across parts of Arizona. In fact, across most of Arizona. Similar story for southeast Utah there. Also for the western slope of the Rockies, it was a pretty dry water year. But then you start to see some green here. This would be on the eastern slope of the Rockies. So Denver would be somewhere right about there. Then you're talking about the eastern plains as we look at down into New Mexico, Albuquerque, somewhere out in here, also in the green shading. So the eastern slope of the Rockies did all right, not too bad. Top 30 wettest years, although for parts of eastern New Mexico, that'd be a top 5 wettest water year. Let's look at California. We'll specifically zoom in a little bit and look at our state. There is a very large difference between Northern California and Southern California in terms of the water year that we just had, right? Well, this is from October 1st of 2024 to September 30th of 2025. For the North Coast and the far northern part of the state up near the Klamath River Basin, 13th wettest water year on record, a top 15 water year. For the Sacramento Valley and parts of the Shasta region up in the Northeast Plateau, 32nd wettest. So it's above average, right, in terms of the overall watershed. We're not talking specifically about Sacramento or one city such as Redding. We're talking about the drainage basin, that is the Sacramento Valley, right? 32nd wettest. And we know that Northern California had a wet year. They had a lot more of the stronger atmospheric rivers, especially earlier in the season. But as we also talked about a minute ago, we had some of those very large wildfires down in Southern California during what would typically be some of the wettest months of the year. It was 111th driest out of 133 years down for the Southern California coast. For the deserts, we are talking about more or less a top 10 driest year for much of the desert. Central Coast, San Joaquin Valley, more or less leaning drier than normal, but you're talking about kind of mid-pack, just slightly drier. It certainly was not wet, right? A lot of the Central Coast, a lot of the Central Valley was running below normal, but we're talking about 80th and 88th respectively there in terms of wettest year. Again, that's pretty mid-pack, but it is on the drier side of things. And this just goes to show you Interstate 80 is more or less that dividing line for no particular reason. That's just how it shaped up. I-80 was more or less the dividing line between who saw rain. If you were on the north side of I-80 and the further north you went, you saw a lot more rain. The further south of Interstate 80 you went, the less rain that we ended up seeing in California. Let's look ahead a little bit, right? That's a kind of brief recap on the water year that we had. Here's what we're talking about for 2026, and some of this comes from the California Department of Water Resources. Number one, as always, is the ENSO stage, right? The El Nino Southern Oscillation. Well, we're expecting La Nina conditions. Now, what's interesting is the La Nina conditions are expected to peak before this calendar year ends, before we even get to 2026. We're expected to enter La Nina, at least in terms of conditions, and then exit La Nina and go back to neutral. That's before our wettest months of the water year, which are December, January, and February. So we're going to keep an eye on La Nina. But of course, the subseasonal activity has a lot to do with that as well. That would be something like a Madden-Julian oscillation, or something we talk a lot about, and we'll touch on more in this video later on, is the Pacific North American pattern. It's important for timing and both for the pace and scales of storms. But the bottom line here is expect extremes. We've talked a lot about this at ABC 10, and the California Department of Water Resources has as well, is that this new era of climate that we are entering here in California is one of whiplash, where we go from long periods of dry to long duration atmospheric rivers, and there's not really a happy medium. It seems that it either pours or it doesn't rain at all, and we have severe clear across portions of our winter months. So let's dive into La Nina a little bit, and I want to touch on, again, that topic of La Nina coming before we get to the wettest months. Honestly, by the time we get to November, early December, that may be as much of a La Nina pattern as we enter to, and then we go back into neutral conditions for much of the deep winter months, January and February and late December as well. That's our wettest months on average across Northern California, and especially true for Sacramento. You see in January, the wettest month of the calendar year and of the water year, we average over 3.5 inches of rain in Sacramento alone. And of course, we typically build a lot of snowpack in the months of December, January, and February. So again, let's move now into the details of La Nina. Right now, as of October 1st, the Nino 3.4 index, roughly this area of the equatorial Pacific Ocean, is about 0.93 degrees Celsius. Once you start moving below 0.5 degrees Celsius in terms of sea surface temperature anomalies, then you're entering a La Nina pattern. If you start to go above 0.5 degrees Celsius, then you start to enter an El Nino pattern. And I want to pause very quickly because the last La Nina update I did, a lot of folks commented on the fact that I was talking about this in terms of Celsius. That is just the standard. When we talk about El Nino, it's the standard for most countries using this system of measurement, right? The metric system using Celsius. So when we're talking about something that has international impacts, a lot of the data that we get and a lot of the data that we use is in Celsius. So that's why we're talking about Celsius. Yes, we can run the conversions and the numbers, but here's why I'm leaving it as it is. Remember what I said just a second ago, when you get about plus half a degree Celsius abnormal sea surface temperatures, you're entering El Nino territory. When you get minus 0.5 degrees Celsius, you're entering La Nina territory. It's just easier because these models, these systems, these setups are all built to use the Celsius scale and not the Fahrenheit scale. That's why we're going to keep it with Celsius. I know it may not make a lot of sense in your head, but the bottom line is you don't have to know what a half a degree or 1 degree Celsius feels like. You just have to know that for the ocean, these are big changes when we're talking about half a degree, 1 degree. Certainly once we start talking about 2 or 2.5 degrees change in Celsius. But here's the forecast as we head in towards the latter half of October into November and then December. This is January, this line right here. And you can see it's only shaping up to be a weak La Nina, quickly moving back into neutral conditions for the rest of the wintertime. And by the time we get in towards the summer months, we're headed back in towards what looks to be a weak to moderate El Nino. Now, these models can change, but when we're only talking about something that's a few weeks away and not half a year or a year away, these don't change so much. We have a much better idea. You can see the spread of the models, all those kind of spaghetti noodles, if you will, kind of how they all roughly follow the same shape, the same course here. But that center line, the black line, that's that expected forecast. That's the center of that model trend, and it's just a very weak La Nina. So that can have some impacts on the type of weather that we see. Something else that we're going to be watching is this blob of much above normal sea surface temperatures out across the North Pacific. This is expected to kind of work its way over to the coast. We don't really know what that is going to do to our winter weather. It depends on where it sets up. If it sets up right off the coast of California, that blob could help to block a lot of the storms from working their way into Northern California. If it sets up a little further off the coast, it could actually help us to build our snowpack by allowing that cold air from Canada and the Arctic to dive across California and the Intermountain West. And so anytime it rains, we could really get a low snow, make a lot of snow and build a snowpack out of it. But we don't know yet how this blob of much above normal sea surface temperatures could impact our winter. We'll get a better idea, obviously, as things get closer, but right now it's just something that we're watching and we kind of have to put an asterisk on because we don't know what this is going to do. In terms of what it looks like right now, you obviously see the blue colors, that below normal sea surface temperature. That's indicative of La Nina. There's some other things that we can look at, though. We're kind of zoomed in, if you will, and so we're just looking at the equatorial Pacific here, about 10 degrees north and south of the equator. These are your sea surface temperatures. These are your anomalies, and what we're also looking at here are wind speeds, and you see all the arrows here pointing to the west. So these are easterly winds, right? They're coming out of the east, and that helps to build La Nina. If we see those winds flip and start to come out of the west, that helps to build El Nino because it keeps that cold water right off the coast of South America, which is all the way over here. Helps to keep that cold water right off the coast and allows warmer water to build out across the equatorial Pacific. But again, that's not what we see. We see the arrows pointing this way, and that's helping to push that cooler water out across the equator. And then what this is showing here is anomalies. Are we seeing wind speed anomalies? No, we are not. We are seeing winds as expected blowing out towards the west. There's one more thing we can look at here. Now, if you will, we're looking underwater. This is the top of the ocean across the equatorial Pacific. And then as we go deeper, and again, remember, we're not using feet, we're not using Fahrenheit. This is an international phenomenon. This is an international product. So we're talking about this in terms of meters, right? You go down 100 meters, 200 meters, 300 meters. So we're looking into the depth of the ocean here, about 500 meters deep. What we notice is we have a lot of cooler water upwelling. This is the coast of South America, right? We see a lot of upwelling right off the coast, and this water is going to get pushed out because we're having those trade winds pushing that cooler water out across the equator. What we're looking at now, same thing, surface of the ocean, 100 meters, 200 meters, 300, 400, 500 meters deep, but this is showing us temperature anomalies in the water. So at the surface, right, we see it's a little bit below normal there, right around 0 to about -1 degree Celsius. But we see this little blue blob here. Well, this is part of a current that moves this water from Oceania, right? And it starts to push it underneath the surface of the ocean, about 100 to 200 meters deep. That current pushes this water out, and this is some cooler than normal water, right? You see -2, -3. It upwells right off the coast of South America, and then will get pushed out across the equatorial Pacific over time. It takes weeks, right? This isn't something that happens in days, but it takes weeks, but this water does move. And what this tells us is that we're seeing reinforcing of that cooler water, right? There's not a lot of it. You don't see a lot more behind it. In fact, this is +1 warmer than normal. But what we see here is there is more blue, there's more cooler water coming, so this is going to upwell and help to build La Nina. It remains to be seen. Are we going to see more cooler water? Or are we going to see a return towards typical temperatures or even warmer temperatures in terms of sea surface temperatures, in terms of water temperatures, because that could mean we may move out of La Nina and start to build El Nino. I know this is a lot of info, but if you're watching this video, you're probably interested in all the details. These are all the things that I look at. I wouldn't necessarily show you any of this on TV because it takes time to explain, but thanks to YouTube and the ABC 10 Plus app, we have the ability to take our time and dive into this data. These are all things that I look at as a meteorologist. These are all things the Weather Service meteorologists are looking at, shipping companies, anyone that has an interest in weather, agricultural companies. We're all keeping an eye on what La Nina is or isn't doing. Because it's important to know this does have an impact on our weather like we've talked about. And while these seasonal models definitely change, they fluctuate a lot more than your day-to-day weather models, they can give us a bit of an outlook as to what we might see over the wintertime. So we're going to go into these seasonal models now and look at it all the way through March, but remember, things can change. And just because a model right now shows it may be wetter or drier, doesn't mean that's actually what's going to happen. The last big winter we had, 22 to 23, seasonal models missed a lot of the large atmospheric rivers that came in. And remember, one more thing. Remember that blob that we were talking about? Not sure how that's going to impact our winter. It may not be taking into account that much above average sea surface. So let's dive into this. But remember, there's a lot of asterisks on this. So we're just kind of gauging what may be there. In October, Pacific Northwest, British Columbia, likely wetter than normal, likely drier than normal across much of the eastern part of the United States. Now we'll move in towards November now. What are we looking at? Very similar. Drier across much of the western half of the U.S., across the southern part of the U.S., but cooler up across the Pacific Northwest and British Columbia. That's typical of a La Nina pattern. But remember, by the time we get to December, January, La Nina is likely to start to break down and we may go back towards a neutral pattern. This could change the types of weather setups that we see. So drier still across the south, that's typical in a La Nina setup, but notice now we're starting to see a little bit more of that rain starting to move a little further south. California, especially northern California, in the green now. That's good. That's indicating somewhat rainy December. Similar here for January. Notice we see a lot more green as maybe La Nina breaks down a little bit, opens up that weather pattern for us and allows some of those systems to dive in. So this is good. Our wettest months so far, December and January, are looking to be a little wetter than normal, according to this CFS seasonal model. By the time we get to February, though, look at that, much drier than normal for February. But now we're talking about something that's 5-6 months down the road. For March, near average, maybe a little wetter than normal, much wetter across much of the Gulf states as you work your way up into the Midwest, the Ohio River Valley. But it's just a seasonal outlook. Things can change. That's why it's important to stay tuned. And a lot of these seasonal models take into effect INSO, right? Whether it's El Nino, La Nina, or whether it's neutral. But one of the things that's much harder for these seasonal models to pick up on are the shorter range patterns, such as the PNA, the Pacific North American pattern. Remember, I touched on this at the beginning of the video. It has a positive phase and it has a negative phase. When it's in its positive phase, we're typically drier and warmer because high pressure sets up overhead or just off the coast, and the low pressures are up in the Gulf of Alaska or across the central part of the United States. So positive PNA, especially in the wintertime, typically means we are going to be drier. When it shifts into the negative phase, though, that high pressure is out across the Pacific or up into the Gulf of Alaska. And that allows these storms to either, one, drop in, could be an inside slider type of setup, drop in from the Arctic, drop in from British Columbia, bring us cooler temperatures, some moisture, or can allow for those atmospheric rivers to just ride right into the west coast. And those can be our really wet setup storms that we get during the wintertime. So in general, when we're in a negative P&A, we are wetter and we are cooler for Northern California, but really for the West Coast, because this is a large enough pattern that depending on where that high pressure is, it'll impact all of our weather. But again, these are much harder for those seasonal models to pick up on. We don't know how the blob will impact our seasonal forecast, right? And we don't know exactly what La Nina may or may not do. It looks like it'll be a weak La Nina moving back into a neutral phase for much of the wintertime. So we may get a setup where we're in a negative P&A for a while, but P&A fluctuates on a time scale of about a week to two, whereas La Nina can take weeks to months to change. So that's that sub-seasonal forecast, right? That P&A forecasting that we'll do a lot of once we enter the rainy season. If you enjoyed this deep dive into the water year and the La Nina outlook, download that ABC 10 Plus app if you haven't already. We've got a weather playlist there with extended forecasts, explainers like this one, deep dives like this one. We also have weather and climate specials, and we have a new special coming out in a few weeks. By the time we get towards mid to late October, we've got another one that'll be up there on the ABC 10 Plus app. It's live, it's local, it's always on, and you can find it wherever you stream. Thanks so much for watching.